Welcome to In 5 Minutes. In this video clip, we will discuss the first type of pulse modulation technique, which is called pulse amplitude modulation. In short, it is called PAM or PAM. As the name suggests, in pulse amplitude modulation, we will vary the amplitude of pulses in proportion to the modulating signal amplitude. Now, this is what we had exactly done in amplitude modulation also, but in that case, we had a continuous carrier signal and we had changed the amplitude of carrier in proportion to the amplitude of modulating signal. In this case, instead of having a continuous carrier signal, we have carrier present in the form of pulses. So G of t is the nothing but a sequence of rectangular pulses that we have taken. These are called sampling pulses, or in the process of modulation, it will be nothing but the carrier signal. All these pulses are of equal width, let's say tau, and if I take the distance between the two pulses, it will be nothing but the sampling time period ts, and sampling time period ts will also be equal to 1 upon fs, where fs will be called sampling frequency. Now, why are we using the word sampling? Because later on you will see that pulse amplitude modulation is similar to sampling the modulating signal with the help of rectangular pulses, something that we have discussed as natural sampling and flat top sampling under the topic of practical sampling in video clips on sampling process. So let's start and discuss the working of the simple circuit that we have in this case. Remember, my output of the circuit should be the rectangular pulses with their amplitudes varying as per the modulating signal. So we have got a circuit where there are two MOSFETs which is being used. One is sampling switch and the second one is called discharge switch. Whenever we turn on the discharge switch by giving a suitable signal on G2, then the capacitor will come across a short circuit branch and hence it will completely discharge. And only once the capacitor is discharged, I can start the amplitude modulation using the pulses as my carrier. So G1 is the place where I'm going to apply my rectangular pulses. So as the first rectangular pulse is applied to G1 terminal, the sampling switch will turn on and it will be short. In that case, X of t, which is nothing but my modulating signal, will be given to the capacitor. Please remember, in this case, the discharge switch will remain open. So as modulating signal goes to the capacitor will now start charging. It will immediately charge to the very first value of the modulating signal, because in the charging path there is no resistance. The MOSFET switch will act almost like a short circuit, and without any resistance in the charging path, the charging will always be instantaneous. Now, as the sampling pulse remain at the G1 terminal, the sampling switch will always be on and the modulating signal is continuously given to capacitor, and hence capacitor will not just charge to the initial value, but it will also change its voltage as per the voltage of the modulating signal.